Hello and welcome to another session of Leetcode. Today we are solving meeting rooms 2, and this is a very common problem asked in interviews. It's mostly asked by Facebook and Amazon. So you have been given a list of meeting intervals, and you have to find the minimum number of rooms required such that you can accommodate all these meetings without a conflict. So for example, in this example, you have been given 0 to 30, so that will take one room. Then 5 to 10 do overlap with the first interval, so you need another room for 5 to 10. And then 15 to 20 can be accommodated in the same room occupied by 5 to 10. So you've got total of 2 rooms. So how do you start thinking about this problem? And what is the intuition behind it? And then how do you optimize on that? So those are the questions you have to ask yourself. And if somebody gives you a list of meeting rooms, I think the most intuitive thing you would do is you would just start iterating over that list and start assigning rooms, and wherever you feel there's an overlap, you create a new room, and then you keep doing this process over and over again. So for example, if you have been given list of these intervals, you start with the first interval 3 to 19, and then you assign it a room. Then you look at the second interval and it does overlap with the first meeting, so you create another room for that. Then you look at the third interval, and then you start looking at each room, so it does overlap with room 1 and it can be accommodated in room 2. Then you start looking at 8 to 12. It does overlap with room 1 and it cannot be accommodated in room 2 either, so you create another room 8 to 12. Then you start looking at 1 to 10. 1 to 10 cannot be accommodated in room 1, cannot be accommodated in room 2, 3. So you create another room, and for 10 and 20 you can assign room 4. So as you can see, this is a brute force solution where I'm literally taking each interval and scanning over all the rooms and finding a room available. So, and also this input that I'm accessing is not in a sorted order, so I have not sorted this at all. So a couple of optimizations we can make. The first optimization, which is very obvious, is how do I ensure that if I know which room to go and look for, uh, then I don't have to necessarily scan all the rooms. So if I have some kind of indication that which room is available at the earliest, then I can start looking in that order. And a good indicator for that is the end time. So for example, if I know that the meeting that took place here ended at 19, so I know that this room is available from 19. And similar idea for here. If I know that this room, but there's a problem since we didn't access this in a sorted order, uh, there will be gaps in between. So for example, if you look at room 2, we are saying that the last meeting ended at 30. So this room is available after 30. But as you can see, it can also accommodate meetings between 7 to 11. So that is why it is important to first sort this array in the increasing order, so you access that uh, by the order of start time, by the increasing order of their start time. If you just to reiterate what I just said with another example, so let's say you don't sort the array. Let's see what happens when you don't sort the array. So let's say you have been given an interval 10 and 20, another is 30 and 40, and then 25 and 27. So you do the same thing as we did earlier. You assign room 1 for the meeting 10 and 20, and you say that this room is available as of 20, right? Because the last meeting ended at 20. Then you iterate over the next interval and you say, okay, the start time is 30 and this room is available after 20, so I can accommodate this meeting as well. And then you update the end time and you say that this room is available from 40. But when you iterate over, when you access this 25 to 27, you see that this room is only available after 40. So you create another room for 25 to 27. And as you can see, it is very evident that you can indeed fit 25 to 27 in this room itself. But the reason is, since we didn't access them in the increasing order of their start time, uh, the result was incorrect. So if you sort them first, 25, 27 comes here. And now if you repeat this process, and then you say this room is available from 20, then you look at the next input and you say, okay, this meeting is starting at 25, which is later than the available time, later than the time my room is available. So I will add this meeting and then update the availability time to 27. And then I look at the last meeting, which is 30 to 40, and then add that as well. So that is why it is very critical to sort this array in the increasing order of their start time and have an indicator which will store the end times of this room, but also align the rooms such that the room with the earliest end time is always available to you. So for example, you could have um, and I'm trying to think of an example where why do you need to maintain the order of the end times? Um, so let's say let's sort this array, and I think we can walk through this example again. So if we sort this array in the increasing order of their start time, and then we repeat the process again. So in the beginning, we take 1 to 10. Then we look at 2 to 7, and the end time for this is 10. And 2 to 7, so and 2 is before the availability of this room. So this room gets, so we create another room for 2 to 7, and we update the availability of room 2 to 7. Now, as soon as you do that, now the priority of room 1 and 2 has changed. Now, now room 2 is available earlier than room 1, right? So now we have to switch the priority of room 2 with room 1. And now if you look at the third interval, the room, which is 3 and 19, you would look at the room which is available at the earliest, and which is room 2. So you look at room 2 and it is not available before 7. So you create another room for 3 to 19. Now, the important thing to understand is if the room you're looking at is not available, none of the rooms below that room will be available, because room 2 is the room which is available at the earliest. And if you have a start time which is less than the availability of the first room, then you would never have a room with a lesser availability, because these rooms have already been prioritized. So what kind of data structure can we use which can constantly maintain the relative order of these rooms by their end time. And a good candidate for that is a priority queue. So if I create a priority queue based on the end times, uh, at the top of the heap, I can always have a room with the lowest availability, just like we did here. And as soon as I find an interval which cannot be accommodated in the root of the heap or in the first room available, I will create new room. And if an interval can be accommodated in that first room, I will update the end time. So I hope this makes sense, and this will be more clear once I start coding. All right, so I'll get rid of this. So first thing we decided is we want to sort this array. And you can pass a comparator, or you can also use lambda. It's up to you. And we said we want to sort this by the start time, right? So if you're not familiar with this notation, all it does is, if this is an equivalent of writing a comparator function, which takes the compare method and return negative values and positive values. And if you return a negative value, then A comes before B. If you return a positive value, then B comes before A. And then we need a priority queue to maintain the relative order. And this priority queue will have the end times. It would be of type integer. And we will have this priority queue with the end time, with the lowest end time at the root. So essentially, we're creating a min heap based on the end times. And then all you have to do is just iterate this array. And you check if the room which is available at the very top can accommodate your meeting. And since q.peak will give you the end time, so if the next meeting you have has a start time greater than or equal to the last end time or the availability of the room, then that meeting can be accommodated in the topmost room. In that case, you remove it from the queue so you can then later update with the updated end time. And that would be interval of 1. And if there's a conflict and you cannot accommodate the meeting in the first room, then you create a new room anyway, right? And then in the end, we have to just return the size of the queue. I'm pretty sure this we have to check for null conditions as well. My typing is pretty rusty. All right, very nice. All right, so thank you for watching, and I hope you understood some part of this problem, and I'll see you in the next one.